We shall now learn an important concept on equal ratios. If A upon B is equal to C upon D is equal to E upon F, then each ratio is equal to A plus C plus E upon B plus D plus F. It means each ratio is equal to sum of antecedents upon sum of consequents. This property is called theorem of equal ratio. If A upon B is equal to C upon D is equal to E upon F, and this continues indefinitely, and if L, M, N and so on are non-zero numbers such that L into B plus M into D plus N into F plus and so on is not equal to 0, then each ratio is equal to LA plus MC plus NE plus so on upon LB plus MD plus NF plus so on. We shall now use this interesting theorem of equal ratios to solve the problems. Exercise 6.3. Question 1. If x upon y plus z minus x is equal to y upon z plus x minus y is equal to z upon x plus y minus z, and x plus y plus z is not equal to 0, then show that each ratio is equal to 1. Solution. We directly apply the theorem of equal ratio and say ER, that equal ratio is equal to x plus y plus z upon y plus z minus x plus z plus x minus y plus x plus y minus z. We now cancel plus x minus x plus y minus y plus z minus z. Hence our numerator is x plus y plus z upon x plus y plus z. This again cancels out. Hence ER is equal to 1. Question 2. If y plus z upon A is equal to z plus x upon B is equal to x plus y upon C, then show that x upon B plus C minus A is equal to y upon C plus A minus B is equal to z upon A plus B minus C. Solution. Let us call y plus z upon A as first ratio, z plus x upon B as second ratio, x plus y upon C as third ratio. Let all these ratios be equal to k. Students, if we see the denominator of x upon b plus c minus a, we notice b and c are in second and third ratios and a is in first ratio. Now, since we have to get b plus c minus a in the denominator, we can use theorem of equal ratio and write ER, which is equal to second ratio plus third ratio minus first ratio. We hence get ER, which is equal to z plus x plus y minus y plus z upon b plus c minus a. We now simplify to get ER equal to 2x upon b plus c minus a. Let us mark it as statement 1. Third ratio plus first ratio minus second ratio. K is equal to x plus y plus z minus x upon c plus a minus b. We now simplify to get k equal to 2y upon c plus a minus b. Let us mark it as statement 2. Similarly, first ratio plus second ratio minus third ratio is equal to k is equal to y plus z plus x minus y upon a plus b minus c. We now simplify to get k equal to 2z upon a plus b minus c. Let us mark it as statement 3. So, 2x upon b plus c minus a is equal to 2y upon c plus a minus b is equal to 2z upon a plus b minus c. Multiplying each ratio by 1 upon 2, we get, hence, x upon b plus c minus a is equal to y upon c plus a minus b is equal to z upon a plus b minus c. This is what we had to prove. Question 3. If a upon x plus y is equal to b upon y plus z is equal to c upon z minus x, then show b is equal to a plus c. Solution. Let a upon x plus y be first ratio, b upon y plus z be second ratio, and c upon z minus x be third ratio. Let each ratio be equal to k. Since a plus c is in the numerator of first and third ratio, let us add first and third ratio and apply theorem of equal ratios. K is equal to a plus c upon x plus y plus z minus x. We now simplify and get a plus c upon y plus z. Now students, notice the second ratio, which is b upon y plus z. Since ER is equal to a plus c upon y plus z, therefore second ratio is also equal to a plus c upon y plus z. Now, since the denominators of left-hand side and right-hand side, which is y plus z, are same, the numerators have to be equal. Therefore, b is equal to a plus c. Question 8. Now students, let us use theorem of equal ratio to solve the following equation. 12x square plus 18x plus 12 upon 18x square plus 12x plus 58 is equal to 2x plus 3 upon 3x plus 2. Solution. Step 1. Now students, the first step is to simplify the terms and reduce to get a simple linear equation. We do this by applying the property of theorem of equal ratio, that is, if a upon b is equal to c upon d, then each ratio is equal to a plus mc upon b plus md, where m is a non-zero number. If 12x square plus 18x plus 12 is equal to a, 18x square plus 12x plus 58 is equal to b, 2x plus 3 is equal to c, 3x plus 2 is equal to d. And if our m is equal to 6x, then we get right-hand side is equal to 6x into bracket 2x plus 3 upon 6x into 3x plus 2. Hence, 12x square plus 18x plus 12 upon 18x square plus 12x plus 58 is equal to 12x square plus 18x upon 18x square plus 12x. Now students, we took m as 6x to get our numerator as 12x square plus 18x and denominator as 18x square plus 12x. So that we can simplify by using theorem of equal ratios, since 12x square and 18x will cancel out. Now we apply the theorem of equal ratio to get each ratio is equal to 12x square plus 18x plus 12 minus into bracket 12x square plus 18x upon 18x square plus 12x square plus 58 minus into bracket 18x square plus 12x. We now open the brackets taking care of the minus sign and change the signs inside the bracket accordingly. Therefore, each ratio is equal to 12 upon 58. Now we write 2x plus 3 upon 3x plus 2 is equal to 12 upon 58. We can solve the equation by cross-multiplying it. We get x as minus 150 upon 18